Hey everybody. Question 2 you see on the screen right now. It's going to look familiar, but it's slightly changed. I'm going to go through and rather than deal with a solution for just vertical and then a solution for just horizontal, I'm going to put it all together. So my challenge to you is, could you come up with all the asymptotes that that function would have under those conditions? Okay, let's jump right in. So let's address the vertical right off the bat. I also want to make sure that we understand why certain restrictions were tacked on to that problem. Like, let's take a look at one right off the bat. I want to examine the restriction of c cannot equal 0. And quite often, to understand why restrictions are in place, go ahead and break the restriction and then see what the outcome is. So, for instance, if we went through and we examined that and you allowed c to equal 0, well, then you're going to get 0 times x, that's going to give you 0. And so that whole denominator would simplify to d. I want you to notice that if d is not 0, then you don't have an asymptote, a vertical one. Because now there is no way to make that denominator equal to 0. So that restriction of c cannot equal 0 just ensures that we have a variable on the bottom, and therefore we can make that bottom equal to 0. So now just jump in and let's tackle the problem. If we were going to take a look at vertical asymptotes, then we should be okay that a vertical asymptote exists when that function is fully simplified. So what that means then is that the factor cx plus d cannot divide out from the factor ax plus b. So they can't be the same. They can't be a constant times each other. Now that's going really in depth. And what I mean by that is, imagine that cx plus d was like 2x plus 3. Well, clearly then on top, my ax plus b couldn't also be 2x plus 3 because then it would simplify and now I wouldn't have a vertical asymptote. But also, it couldn't be, let's say I double both of my green, a 4x plus 6, because now my top would factor and then I would be able to divide out a common. Okay, that's going really in depth, and I mean really in depth. But it is important for us to consider, okay, the top and the bottom still cannot be factors of each other or share a factor that divides out the variable. Okay, if we presume then that cx plus d and ax plus b are completely unrelated, then we know that we can find a vertical asymptote wherever our denominator equals 0. What creates a divide by 0 scenario? So we should be good then to get rid of your d, divide out your c, and there is your vertical asymptote. Okay, you're not required to examine the nature of that curve because clearly without the a and the b, the c and the d, we can't really tell whether the function is increasing or decreasing towards that asymptote. Okay, there you go. There is your vertical. Hopefully not too bad. Okay, let's jump into horizontal. Okay, I want to deal with horizontal for this problem. So we're going to address horizontal. But I also want to go back and address those restrictions again. And in part, that's going to have a different effect this time. When we address the restrictions, the fact that a cannot equal 0 and c cannot equal 0, again, that just ensures that we have a variable on the top and the bottom. What it also assures is that we have the same degree on the top or the bottom. If a and c cannot equal 0, then you're going to have a linear factor of x on top and a linear factor of x on the bottom. Top and bottom are going to be the same degree. Okay, why does that have an impact? Well, I'm going to go through the proper way, good, solid theory for us on where the asymptote exists for that function. And then we'll talk about a little bit of a shortcut you can see that you can use as a check. Okay, my question to you would be, how do we find horizontal asymptotes? Well, we examine the curve to its extremes. So you are going to examine the limit as x approaches positive or negative infinity, make it huge in both directions. And then what we do is we divide that whole function, top and bottom, by x. You can skip all of that stuff, just as I've talked about in class. You don't have to show me ax divided by x plus b over it. You don't need to show me dividing by the largest power of x and then simplifying. Put it right into your limit. So we're going to get an a plus b over x all over c plus d over x. Okay, now that we have our function in that form, we can examine what happens when we go to our extremes. We know that since we're going to imagine subbing in huge values for x, our limit notation's gone, we are performing our limit. There is nowhere to sub it in for a, so I have a. And now, when I see my b over x, don't get distracted by the fact that that top is a b. It's still just a constant by definition. So if my top is constant and my bottom gets bigger and bigger and bigger, then that means that whole fraction is going to approach a value of 0. Now, if we were going towards positive infinity or if we were going towards negative infinity, that would impact the sign of that bit. Are we subtracting a bit? Are we adding on a bit? But because we don't know the sign of b either, really we've got a plus or minus a bit in there. Okay, on the bottom, nowhere to sub it in for c. D over x is also going to approach 0, and for all that same reasoning, we don't know what that is either. Okay, now we are going to evaluate our limit. So those bits, those zeros, are so close to 0, treat them like they're 0. And then we would have the discussion over they're not really 0, they're really bits, and therefore is the top really a little bit bigger than A? Is the bottom really a little bit bigger than C? So on and so on. We don't need to do that for this function. Because we don't know what B or D are, we don't really know whether our value is a little bit bigger than A over C or a little bit less. Your asymptote is y equals A over C. There you go. Good sound theory that gets us there. Okay, now for discussion on the shortcut. If you take a look back up at the white function that I gave you on the very top line, I'm hoping that you can see that when we have the same degree on top and bottom, our horizontal asymptote is always going to be the ratio of those coefficients. But you can see it in your gold limit. Because b over x and d over x are going to approach 0 when we allow x to become huge, to become big and always keep getting bigger, then what we're going to be left with is the constant. Or sorry, the coefficient. And so as we work our way through that limit, in gold, I hope you can see why the trick works. Now, I want to make sure that you are good for evaluations. I need to see the gold. But that doesn't mean that you can't use that shortcut, looking at the coefficients when we have the same degree, as a means to check the outcome of your limit. Okay. There we go. We took that problem. We found a vertical asymptote and a horizontal asymptote. I hope that helps you with your practice. Keep it going. Good luck.